Hi, and welcome to the third of our four-part series on value streams. My colleague Sahil Panikar introduced you to value streams in session 1, and then he talked about operational value streams and development value streams in session 2. I'm going to carry us forward in talking more about those development value streams and how we organize around value and test the team design in those. By now, you've seen our pictures, you know our specialties, we're practically related, so let's move on. This is an example that Sahil showed you in session 2. And it's an example of a development value stream there at the bottom that produces a software as a service solution that then the operational value stream of the company is used to sell and support. So the question now is, how do we organize the people into teams or teams of teams to best support this development value stream and the delivery of value to these customers? Here's another example where we saw this loan application and learn delivery operational value stream supported by some applications. And Sahil said, let's organize the channels application, loan origination system, and credit scoring system into a single development value stream. So this could be the core loan business piece. Again, how do we organize the teams to best support the flow of value? It's going to be different for different development value streams. We need to look at what are the skills needed? How many of each kind of skill do we have available? What percentage of those skills? Is this something in a regulated environment where I have to have some compliance? In our other example, the delivery channel of software as a service was something that would impact how we organize the teams. So we're going to use this example in particular to examine some of the underlying principles for organizing around value, and then we'll do a trade-off of two different options, and we'll show you how we test those different options to help us make decisions about how we organize the teams. You ready to go? First of all, we're going to look at the architecture. Now, I conjectured an architecture for those three applications that we just looked at. I wanted it to be simple enough to support our concepts here. So it's a simple three-layered architecture with an underlying platform that provides analytics, persistent data storage, then a business logic layer supported by the people who understand the business rules and the business side of the applications, and a user interface layer supported by people who do design thinking and understand user interface design and user interaction. So we're going to come back to this architecture in a minute, but we'll talk about the strong correlation between the underlying architecture and how we architect or design our teams to support this. Now, Scaled Agile framework and based on an underlying principle of Agile says, you know what, the best, most efficient way to develop something is with a small, cohesive team, really 5 to 11 individuals, and we need them to be all the skills that are necessary to deliver beginning to end value to the customer. So it is a good principle. In practice, we often have trouble finding all the right skills and getting them dedicated to a small team. We also often have systems that require more than one 5 to 11 person team to build and maintain. So what we need to know, this is a summary of the things that I mentioned already. what skills we need, how many people, what percentage are they dedicated to the work, what other, we'll call them non-functional requirements, including the ones I've listed here, might be necessary for the teams. We looked at the architecture. And we also need to care about the process that we're using to support this delivery of value. And why is that? Because different processes will have different kinds of roles and the way that the work is enacted to provide the value. So let's look at that for our example. The goal of our virtual organization design, and we say virtual because we can organize people around value without having to completely reshuffle and reorganize our organization, our hierarchical organization. Our goal is in organizational design the same really as it is in system design. We want loosely coupled components. If the components in your organization are teams or teams of teams, we want to minimize the dependencies between them because we're all about removing bottlenecks and supporting the flow of value and the sustainable flow of value. So we want our organizational components to be loosely coupled. And we want each component, like a team, to be cohesive. We want a single, non-ambiguous purpose. We want clarity of what this team is delivering. What's the value that this team is responsible for? And then lastly, yes, we want those small teams, cross-functional teams, and ideally we want them long-lived teams. And this is where we get into organizing around value as opposed to organizing around projects. And with a project-based focus, we can rip apart teams and reassemble them, depending on the project that they're working on. And as a result, they incur this additional cost of team formation and getting to know one another. We need teams that learn how to work together and can work well together because they know each other. And yes, this last bullet around what I call team elasticity, we need a team that their common mission is this delivery of value. And it might mean that sometimes as a team member, I have to step outside of my comfort zone of my skill set and learn a little bit about the other things going on in the team and figure out how I might contribute so that we have that ability to adjust based on what the team is learning and doing and what they need to deliver that value. So Agile teams and the Scrum processes represented here have been a long-lived success pattern for how to best organize a team that delivers value. And why is this? What makes this powerful? Well, you have people with these different skill sets and perspectives, but they're all working off the same backlog. Meaning it's a common set of work and they learn from each other about the details of that work and how it contributes to the value that they are providing. They plan together and they work together in a cycle called an iteration, also known as a sprint. And during that iteration or sprint, which is normally 2 weeks, sometimes 3 weeks, they will gather together every day. They'll huddle together like a football team does before each play, and they will understand where they are, how they could help each other out. They want to react in real time to what they're learning and how they are working to achieve that value, not just their individual pieces of the work. Then at the end of the iteration, they demonstrate the work. There is no better way to understand exactly what it is that we're doing and what does it look like to the customer and what does it mean. And we get that common understanding with the team and with the customer during a demonstration of what the team has done in an iteration. And then the most powerful part of what an Agile team using the Scrum process does is they do a retrospective. They study what they did, they innovate on what they could do better, and they make that work of improvement, relentless improvement, they make it an integral part of how they work. And so this is what makes that small, cohesive component called an Agile team so powerful. Now, most of the systems in the world require more than one small Agile team to deliver the value. And for that reason, we have some ways that we can scale these Agile principles and practices. And here I'm representing a set of teams who are working in this cadence of sprints. And they are planning together for a set of sprints or iterations and understanding what is it going to take for us collectively to deliver value over a set of iterations called a program increment. And the most powerful thing that we do when we plan together is we determine what are the dependencies across our teams. And those are represented here with these red arrows. Now we really want to try to minimize those dependencies. And why is that? Just like our football team that can huddle before every play, right? We can't get everyone in the league together before every play. That's not practical. And so the communication element is really easy within a team. Communicating and collaborating across teams, certainly possible, but is not as efficient as collaborating within a team. So our goal is to minimize these dependencies across the teams in order to support the flow of value. Now, we've looked at the teams. How we organize those teams has a strong correlation to the architecture. Since 1968, in fact, Melvin Conway has given us the quintessential description of that connection between teams and architecture. In fact, he came at it from the viewpoint that, what we see, unfortunately, the structural organization of the components supporting the system often defines the architecture. The architecture of the system will often morph to represent those communication structures in the organization. So he's given us that guidance that organizing around value needs to be, the organization side needs to be strongly correlated to the architecture, lest we build architectures that become unmanageable and unruly over time. Now that was Conway in 1968. More recently, our authors of this book, Accelerate, have taken it a step further. And they have defined this reverse Conway maneuver. And they've said the goal is for your architecture to support the ability of the teams to get their work done. from design through deployment without requiring that high bandwidth of communication. In other words, keep that communication and collaboration element as streamlined as possible. So here's another way to look at that correlation between architecture and organizing around value. Now here we go with our example. Let's go back to the one that we looked at earlier. This is here for a refresher. Remember, we've got 3 different applications. Look, interestingly at the top, it looks like each of those applications has a different set of users. And those different sets of users are accomplishing something of value on the operational value stream, ostensibly quite different from the others. So we need to keep that in mind as we organize around value. So I'm going to show you 2 options. The first one is a default we used to always go to. It was simpler, right? We organize teams around skills. Why? Because we say, oh, all the user experience designers, all the graphical designers, they speak the same language, they know the same tools, they are easier to manage because we can compare them to one another when we're looking at performance management. And so this is how we get to these skill-based team constructs. And so in option A, we've got a user interface team responsible for all the user interfaces across these 3 systems, the business logic team, and then the more we move the underlying infrastructure along some trends like analytics, cloud hosting, then we've got those specialized skills, and we keep those together for the same reason. We're also probably sharing some of these infrastructure skills even across other development value streams. So what's the impact? Well, the impact is when we need a change to a single system, the flow of the work often gets bottlenecked behind specialized skills. And I'm going to go into that much more in our next session 4. So here's another option. What if, crazy idea, what if we took the user interface people and kind of divided them up and made specialists for the channels application and had specialists who know business logic for the channels application, and then even down in the infrastructure layer, we have to ask ourselves, what are the aspects of the infrastructure? The analytics specific to channels? Oh, that makes sense. How do we get these specialists that can deliver and responsible for the value provided in the channel system and keep those as a cohesive unit? So you see the pattern here. We still need some support for the underlying commonalities, so we pulled that out as a platform support team. Here's option B. Sounds good, right? But maybe it's still not 100% clear which option will work best for us. So we have a way to test that. And the way that we test that is we can use current or previously implemented backlog items and assess what cross-team dependencies were required or could be required to implement them in the future. Because our goal is to select the option in our team design that minimizes those cross-team dependencies for these reasons that we keep harping on. And Sahil mentioned this in session 2, but I'm going to show you an example now. Let's take our architecture. Let's look at a feature that we implemented previously. Oh, clearly this is something that fits within the boundaries of the channels application. And I put circles on here to depict these are the parts of the architecture that we needed to touch to implement this feature. When we look at this, it's pretty clear that option B would be our organization of choice. But we need to test more than one. Here's another one. Here's a feature which we would call an enabler feature, because this is something that the end user won't see, but it's necessary to support our architecture and all of the applications. So we see here that the work used to implement this feature, in fact, was mostly in user interface and the infrastructure layer, and so it was more broad than narrow and deep. Oh, gosh, if I only looked at these two test cases, I've got a dilemma. How do I pick? So what we will do then is, these are two patterns of the kinds of work that we might need to do. We'll go back and analyze the full set of work, either historically or in our plans. And in fact, let's conjecture that here we analyze the work, 90% of the features map to that first one that I tested with, and 10% of our work map to the enabler kind of work. That's not uncommon. So that leads us to option B. Let's go with option B. And in fact, this thinking through how we're going to organize, how we're going to streamline the work, could also lead us to something important that Sahil depicted in session 2. We could say, let's look at the market rhythms, let's group up all of the enabler work, and let's be sensitive to market rhythms, because if this is all underlying work, it could introduce new risk or impede the progress of getting the real, user-facing features that we need. So we could use that combination of what we're doing here and that concept of market rhythms to help us plan and organize not only how we organize our teams, but how we plan out our work to deliver value most efficiently. So here's my summary. Our 3 takeaways: structure the teams to minimize bottlenecks and support flow. If this means that we need to invest a little more in mentoring or reorganizing the shared services kind of people, making them more specialized, then that's what we need to do. We showed how the team design is dependent on skill needs, skill availability, the architecture as well, and the characteristics of the development value stream. The reason that we reshuffle teams on project-based work is because, we're trying to piece part these different skills around, and the trade-off is this impeded flow of value. It's lack of ownership of the delivery of value. And so there's an economic view to that trade-off that we need to consider. And then lastly, I showed you an example, albeit simple, on how we can test alternative team designs with our backlog items, either future or previously built. So that concludes session 3. I hope you found that quick run through helpful. Please go back and review at your own pace, but also feel free to reach out to Sahil and me for further discussion. Your problems are probably much more complex than our simple examples, and we have experience working with organizations with those kinds of complexities, helping you learn, pick an option, experiment, relentlessly improve. Those are the hallmarks of Agile, scaled Agile, and lean practices. Thanks for your attention, and I hope you'll tune in to the last of our 4-part series called Team Topologies Applied. Hello, and welcome to our fourth of a four-part series on value stream management. I'm Cindy Van Epps, collaborating with my colleague Sahil Panakar, and we are excited to show you this last of the four-part series. So this section will be based on a book called Team Topologies. It's a great book for helping define better how we organize around value. Now, I'm not going to go through everything in the book or all the concepts, but what I'm going to do is take you through an example of how we could apply these concepts in the book, and so you'll learn some of the elements of this along the way. Remember from session 3 that we highlighted that the best way to organize around value to streamline that flow within a team is to have all the team members that have the skills necessary to support that development value stream. That is the end-to-end flow, the delivery of value. We also acknowledged that that's sometimes hard to do. And that's because people ask questions like this. What about information security? They're kind of a shared service. Should they be outside the team or part of the team? Should I have teams based on a feature in the system or components of the underlying system architecture? How do we do this T-shaped skills thing where people are more than just a single specialty of skills? And especially in a very high engineering kind of environment where learning the skills of the other team members is not a trivial activity. Why don't we just take our hierarchical organization and make that an Agile release train, that is a team of teams, and then have each manager and their direct reports on an Agile team? Do I need a finance person on each team? These are the kinds of questions that are a function of the kind of development value stream, the nature of the work, the things that we talked about in session 3. Now, I'm going to use an example from some work that I worked on last year, helping a team in a large organization move their applications from data centers to a cloud-hosted environment. I'll call that the cloud hosting example. So in that example, because they were moving to the cloud, they now had the ability to implement artificial intelligence, analytics, machine learning afforded by the underlying cloud platform. But there were several teams, in this case teams that each supported a different application in their environment. And now that they could be in the cloud, they needed help with AI and analytics, a skill that they didn't necessarily inherently have. Now, there are tools available and training available, tools like SageMaker in Amazon Web Services that allow you to learn the skills around analytics, but just taking a class does not a wizard make. And so that's a specialized competency. We'll look at the options for taking people with that specialized competency, that is skills and experience, and how do we allocate them or collaborate with these teams that need that help. So how are we most likely to organize? Here's some options you could read through and make a decision on your own. When I poll people with this question, interestingly enough, I get kind of an equal response on each of these. My experience is that people generally start out with option B. They form a single team of all the people with the competency. And sometimes it makes sense when we're introducing a new capability into an organization, like AI and machine learning. So what we want to look at now are these three options. What would be the best of these three options in our organization, and what are the trade-offs and considerations? So I am going to reference this book by Matthew Skelton and Manuel Pace, and I'm not going through every bit of it, but you can purchase the book easily. There's also an advanced topic article on how to apply this to team of teams in the Scaled Agile framework. So let's think about the basic parameters for analysis of our options. How many people do we have with that competency? How long does it take to develop and maintain the competency? These are the two key elements of the supply. Then what's the demand? How many teams need it? How often? On average, how long does it take for someone to help an application team apply the analytics element? Another key thing is, how important is it for the competency provider, meaning someone who understands analytics, how important is it for them to understand that application team and their context? Now I'm introducing here this term, stream-aligned team. That is a term from Team Topologies, and it means like the development stream, the people responsible directly for the end-to-end delivery of value to a customer. So how important is it for the analytics provider to understand the application for which they're helping provide analytics? And what is the effort to understand that context, that application? And then lastly, how critical is it that we have consistency in how we provide analytics across these different stream-aligned teams? So these are the things that we want to look at when we look at our three options. So do I allocate one analytics wizard per team? Now I've designated in yellow our stream-aligned teams who are providing the value for the customer. I could allocate one per team, and this is actually the preferred scenario if we can afford to do it. Now, why do I say this is the preferred scenario? Harken back to our underlying principle for organizing around value. We want to remove bottlenecks and support the fastest flow of value. So I have one analytics wizard allocated to each team. They know the context of that team and the work. They are working with them on a daily basis. Yes, you might say, but what about the need to be consistent across teams? We can form a community of practice around analytics. What about if I can't keep them fully occupied as an analytics person on a team? Perhaps they can help the team in other ways. These are the things that we want to look at. So let's look at that supply and demand. If we have enough people, if our ratio of people with this competency to the teams needing the competency, that is our supply versus our demand, our supply is at least one, meaning we have at least one person we can allocate, this is the best approach. So if not, and we don't always have that luxury, we need to understand how many additional people would we need to achieve this one-to-one, and what would be the investment required to develop that competency. Okay, and so that investment, if I'm keeping up with information security, that is constantly changing, that makes it a more significant investment. If I have a one-time upfront cost, like I worked with the aerospace company where they had thermal analytics they needed to apply to their different solutions. Heavy upfront learning cost to be a thermal analytics specialist. So if that investment's unacceptable, let's look at our other options. Do I keep that group of wizards as a complicated subsystem team? Complicated subsystem is yet another term from team topologies. And that means that the work that they do is so specialized and the investment to learn it and keep up with it is high enough that it warrants us keeping them as a separate team. So then what they would do is provide help on demand to these stream-aligned teams. Now this can be a very good model. Where it goes wrong is I've often seen in large organizations, they will cordon off this set of specialists and say, in order to get analytics help, you have to submit a ticket through our support system and request this help. And then for those stream-aligned teams trying to deliver value, they have no transparency into the prioritization scheme for that specialized competency team. There is no one negotiating the priorities across those needs in a way that's focused on customer value. In fact, it's usually a first in, first out kind of queue. The other challenge with this is that if you have someone on this complicated subsystem team who's never worked with your application before, they have to ride that learning curve of understanding your context. And so that also can become a bottleneck to the flow of value. So let's consider that ratio of supply and demand and what would be the bottleneck. What's the response time? What's the average response time to get that help? I've worked with an organization where everyone in the organization, actually several enterprises I've worked with said, oh, information security, that's our biggest bottleneck. And so who is really managing, who's measuring the magnitude of that bottleneck and the impact to delivery of value? My experience is no one, right? We're working in our silos. And yes, information security has become incredibly critical in today's world. And so in some cases, that information security silo is kind of driving the bus and it impedes the flow of value. The second one we talked about, understanding the streamline team's context. So using the shared pool of resources can result in rework, inconsistency for different analytics people working with those teams. But also sometimes when we have a new competency, we're needing to discover how is analytics best applied in the kind of applications that we build. And so that's a reason that sometimes people keep those specialists together, is because of this need for discovery. Again, we can offset that by using a community of practice model. Now, if we find that this risk of bottlenecks is very high, we can look at our third option. Now, in the Team Topologies book, they call as a service a communication mechanism between teams. I call this competency as a service as an option, just because this is the way that I like to think of it and teach it. So let's look at what that means. Competency as a service would be where my team of specialists say, what is the highest 80% of things that people need to do in analytics? Can I create some templates in SageMaker? Can I give them some self-service kind of help and examples so that these stream-aligned teams can become self-reliant in the major part of what we need to do with this competency? And then I take my wizards and they become enablers in this enabling team construct, and this is a construct that the Team Topologies books uses called enabling team. They would enable those teams to be self-service, and then they would also provide the additional maybe 20% that's not the normal mainstream, the more difficult, challenging, interesting things that these application teams need to do. Maybe they encapsulate the 80% behind this as a service interface. The 20% you can also get help from that team, and then they're enabling you how to use that as a service component. So that's our competency as a service model. So how will we evaluate whether that's our best option? We look at these kind of questions. There's an investment in building this competency as a service. It could be a website, it could be some tools, it could be microservices that you inject to support, say, information security. And so what's the effort to build and maintain that? That is something we call the cognitive load, meaning what has to be in the head, the knowledge of those competency providers, my team of wizards. Second, we want to look at what's the effort to educate and support each team to use that service compared to those interactions of requesting and getting service. So this is what I call the collaboration load. So that is the effort to get to this competency as a service element. How much time do we have to spend working together for learning the competency as a service versus the effort of having the complicated subsystem team just provide it on demand. And then lastly, what is the effort once they learn this competency as a service? What's the effort for them to be self-serving? In other words, what do they have to keep in their head and remember to do? And that's the team cognitive load. So these are some parameters that we've used to help us trade off these different options. Wow, Cindy, if only we had a tool. Do you have a spreadsheet or something that we could plug in numbers and help us? Well, indeed I do, but it's better than a spreadsheet. It's a calculator. It's a calculator / advisor. Now, I have a lot of value calculators, and there's a link there at the bottom of this page. Something as simple as what is the impact of the organization of the cost of context switching. So when we see calculators, when we see numbers, sometimes we go to, wow, it needs to be very precise, very deterministic. However, this one in particular is estimating, best guess. What do we think are the costs, right? Based on average. What is the most reasonable value for the average cost of getting a response and getting help from a complicated subsystem team, for example? And if you want to feel more comfortable about that, think about calculators we use in our everyday lives, right? You might need a mortgage calculator. That's very precise. How much is my payment every month, and how much of that is going to interest and how much to principal? We want that to be very precise. But there are other calculators. For instance, how much money am I going to need in retirement? I can't precisely predict how much medical costs I might incur. I can't precisely predict how much my investments are going to make year over year, or how much travel costs might change. So this particular calculator or advisor is in that second camp. Let's make some good enough estimates. So it's going to collect information on the supply of the competency, the demand for the competency, the parameters I talked about, assess the fit for the designated team member model, right? Whether it's one specialist per team, a complicated subsystem team, or the competency as a service model. And it provides recommendations. It's going to assess these different options and give you recommendations. So before we wrap up, there is a lot more in this Team Topologies book, and I highly recommend that you read it, digest it. And so I found this on the teamtopologies.com site in, kind of community supplied tools. And so you can see there's a lot more around this. Conway's law we talked about. We touched on cognitive load. We touched on these kinds of teams here on the right. I didn't go into detail about platform teams, but you can read about those, and here's a handy one-page reference. So that was a quick run-through of an example of how you can take that idea of organizing around value and looking at different trade-offs. Yesterday we simply tested two simple models. I say yesterday, that's when I recorded session 3. We tested two simple models using different features. And today, in this session, I am showing you a more detailed analysis, because in the real world, those trade-offs get more complicated, have more nuances and options. And so this is why today in this session we looked at team topologies and the concepts here, and walked through one example of how you would apply that to help optimize the flow of value, particularly for your development value streams. Again, I hope that you will reach out to Sahil and me for more discussion and interaction. Thank you very much.